You want to check the video feed and see if that looks okay for you?
Maybe zoom in a little more and more. Yep.
Like this?
Yes.
If you need to adjust it, you can use this as a zoom on the side until we get that fixed. But again, we'll come back after your class, so I don't have to interrupt anymore.
Super, super. I hope you are enjoying the start of the semester and let's be tolerant to each other and to the technology. So the goal, I don't know what's the goal, of course. I just need a record of mumbling something in front of you, you need grades, and you can stay friends. There is a hope that activity in this class will help towards your career goals, research, teaching, whatever industrial jobs, and to other classes that you still need to take in the future. So the outcomes of this class are expected to be really helpful for anything in the future track of physical chemistry, in organic chemistry, and there is an elective course in computational chemistry. This is direct connection. Maybe it will be helpful to other things. The didactic academic learning, do you like it? Do you like learning and doing homeworks and exams? Or it is a provocative question? I hate it. Well, we need to follow the rules and do a little bit of that, but the learning for learning could be a little too abstract. So some of you have already got practice in working in labs, right? Doing wet chemistry, and as intellectual adults, you probably are gauging each piece of information, like, does it help me to go across my lab goals? Does it help me? And if you decided to do more things for the research and the lab, you are gauging it. Is this piece of information valuable for helping you to start reaction, or it is just entertaining show that I can lean back and sleep until the end of the class. So in addition to standard wet chemistry, synthesis and characterization, there is a theoretical chemistry and there is computational chemistry, which means one can interpret, understand, and even predict outcome of certain reaction or the property of a certain molecule without making your hands wet. And this overarching goal of the science, like being different from set of recipes in alchemistry, it's kind of useful approach to try to connect loose ends and get some understanding of the principles. Some people think that practical applications are superior because they will help civilization to live more comfortable, to feed diseases, or to get free energy. Some people think that knowledge for knowledge is cool, and just getting this understanding of basic things is important. But neither you nor me have choice. We need to survive over this, whatever, 4 months, right? And I will try my best to make connection between class materials and real life. Of course, I do not have equipment and license to bring here something that will explode and burn and change color in a wet chemistry sense, but we can look on the convert properties of the molecules on the language of math and try to understand at least some very basic of them and predict what could come out of the experiment, either as a reaction or as a characterization. And if you are accepting this general philosophy, then the rest are just technical goals. So main philosophical idea behind the course is that electrons are waves, which probably we all are quite educated citizens of 21st century, and it's not a big surprise for you. It was a surprise maybe at the beginning of 20th century, but the properties of like molecules, what are the molecules? Can you help me? As professional chemists, you may give immediate definition of molecules. What is a molecule, philosophically? Do not hesitate, it's not for a break, you're just helping me to mumble the lecture. What does it consist of?
Atoms.
Yes, and atoms consist of
Protons, neutrons, electrons.
yes, and if we want to be not so wide and more narrow thinking, it's like positive nucleus and negative electrons. So a molecule is a collection of ions and electrons flying around each other, sometimes forming stable bonds, sometimes migrating, right? And if we are looking on the ions, we can think in the standard way as we did through the whole regular life as just reasonable people without any connection to science and technology, just setting up position and telling like the ion is sitting in this point of space, and molecule is like a set of spheres connected by sticks, right? You're fine with this. But if we live in this paradigm, and if we do not have wet chemistry labs, if we want to use some concepts, logical connections, and predict properties, we will fail. I'm not going to prove how we will fail, but we will fail epically. The most important philosophical part of today's science, natural science, like physics and chemistry, that the electrons are what? Particles or
Waves.
yes. So the electrons do exhibit wavy nature. So one cannot speak about electron sitting in a specific point of space. It's always like a wave distributed around different places, has minimum, maxima. And even in atoms and molecules, they always exhibit this nature. And without getting deep into the features of this wavy nature of electrons, our hands are tied. We cannot understand, interpret, and predict experiments. So broadly, we can tell it is PK1, quantum theory. Narrowly, we can say it is wavy nature of electron in relation to chemistry. And if you do not protest against the second concept, so first one that we want to predict, interpret, and understand experiments. Second, that we need to learn how to live with a concept that all electrons are waves. And if you accept these two basic concepts, then we can slowly speak about technical aspects and start procedures along the course. A few minutes ago, I did promise some connection to the real life. And I want to stay as, to minimize the lie from my mouth. as much as I will try to do it as much as possible, but without wet chemistry lab. So the way to implement connection to the real life would be to pump enough mathematical muscles or theoretical muscles in the understanding basic concepts, and then apply them to some more or less practical, more or less realistic applied problems. And during the last month of the semester, you will select individually which problem is near and dear to your mind and heart, and try to apply skills from the class to explain it. And main outcome for the grade will be a little written report, like research paper, and oral presentation on the project. So I do not know if I'm allowed to do so or not, but I want not to serve as a distribution machine for the pieces of didactic knowledge. I want to change paradigm of your thinking and intervene in the way you're thinking, in the following sense. Right now, I make a hypothesis. You're gauging each piece of new material, like is it useful for me or not, in a sense of either career or practical research you're doing. And I want to add one more judging aspect. I would be happy if you would gauge and judge each new piece of information. Is it useful for the research project at the end of the class? So if you will be not well, if we do only lecturing, I'm mumbling something, you're listening to something, it may look like a set of abstract concepts and maybe some homeworks, which some people get irritated from this, but it's not free of real life abstract things. They all will be set up in order to be used in the project. Okay, this is the third thing that I hope you will accept. Oh, I think I'm done with concepts. And if you have more time, I'll show live abstract things. They all will be set up in order to be used in the project. Okay, this is the third thing that I hope you will accept. Oh, I think I'm done with concepts. And if you have more time, I'll show maybe syllabus, and if I'll show syllabus really quickly, I can start like a couple of slides in the lecture. So it looks like Zoom meeting is working. At least I can connect it as a host and as a client. So you may try it, although face-to-face is much better, because even if half of our faces are hidden with mask, I can sense expression of question or expression of sarcasm or presence of lack of enthusiasm, yeah, and then adjust our pace. But just in case if some of you need to travel or stay home, or there are some circumstances, it's better to test this stuff. For the practical things, we will do something that we can call a lab. But it will be not wet lab. Some of you have visited the 132, right? And you've noticed that there are no fume hoods. So there are only computers. There will be a software installed there, and we will be, all of us will be welcome to use it, but I am enthusiastically encouraging you to install correct software on your personal computers so that you will be completely independent. So the name of the software is MATLAB, not as mathematics, but as a matrix, MATLAB. And since you are registered within DSU, you have privilege to download, install on your personal computers free of charge. If a stranger wants to do it, it's something like a couple hundred for a student, 500 for academics, and a couple thousand for industrial. So it's not super expensive, but it's better to use it for free. And why we are bringing in this software and little scripts under it? I wouldn't be surprised if I learn through one-to-one interview that some of you hate calculus and math. But fortunately or unfortunately, the modern science cannot live without it. But there are shortcuts. And shortcut is to replace as much as possible solution of problems with pen and paper with running computer codes. So I cannot discount all like building of mathematical concepts and equations that I needed to describe these molecules and electrons and their chemical properties. But we can, wherever is possible, to replace exhausting mathematical exercise in deriving equations with running scripts and computer codes. It's not 100% possible everywhere, but for each application. But if we use this additional wing, the life will be a little more interesting and definitely easier. I hope you are buying this argument. And if you want to meet one-to-one, I think we can stay after this lab, finish it earlier and discuss one-to-one, or we can schedule just a one-to-one Skype or Zoom meeting if you really need. Books? No books. Why should you spend money on books? If you really want to read something, you can find those things, and they would be like auxiliary. But while designing the course, I was taking a little bit from here and there, and there is no single book that would one-to-one correspond to the narration of the material. And they are going from simple to complicated. Like if you just read this book, you will beat me in everything. You will be able to teach more advanced course this one. It has all information that we need, but it is diluted with a lot of additional information. It's not complicated in the style. They try to slowly but surely write all little thing. So it is the easiest of the complicated books on quantum theory, but it's like 1,000 pages. This one is ideal textbook for third-year undergraduate studies, but it misses some concepts. It's I wouldn't say that it is childish, but it is what to say. It's more digest rather than cornerstone. This one is standard text, undergraduate text for physicists who need chemistry, maybe even more than who need quantum theory even more than chemists. But it's also text for studying, so it is digestible, and therefore some concepts are oversimplified. This one is not a textbook. It is just a set of problems and solutions, and probably the best condensed overview of most important problems. And if there are I cannot cancel all homeworks. I need to do some of them. And if you look for solutions online or in this book, I don't. If you find the book and then the solution there. Okay. If you invest time into presentations and projects, you'll be fine. You shouldn't worry much about the grades. So I will try to do some homeworks, like assigned a week ahead, then boarding class a week after, something that one can do in a reasonable time. Then we will have like 4 presentations about once per month, maybe a little more frequent because semester is shorter. Once I'll tell about it later. And if you perform well, the presentations will weigh heavier than homeworks. So you should focus more on presentations rather than homework, although they all are helpful in getting through the material. So I just looked on the calendar when will be the Fridays, and I suggest we will make presentations on Friday so that you'll have a weekend free and relaxing for other activities. And if you have the lab on Wednesday night, then one can use this time on the lab as time for preparing presentation on Fridays. Here I just copy pasted some mandatory things, and here is the tentative plan of the class. So if you're interested, you can look there from time to time, but I will be sketching the plans and updating our navigation in the space of ideas frequent enough. So it's only if you're curious to see what is going on and if you want to make correlation between any textbooks and what we're doing in class. Okay, any enthusiasm, lack of enthusiasm, curiosity about syllabus? Any suspicious things? Anything you want to improve, to remove? Enthusiasm, lack of enthusiasm, curiosity about syllabus? Any suspicious things? Anything you want to improve, to remove? Okay. So let's jump to coming Friday. No rush. I will just start mumbling and we will live in time today just so that we put seeds of thoughts for our next meeting. So here is the chapters of this course, and typically by the end of semester there is no time and there is no time for last things. So we are finishing about here, 42 minutes. And the chapters are fundamental ideas of moving electron, the principle of uncertainty. There is nothing with sport books, in particular the books which is the simplest problem that is part of any textbook. Then oscillations, because molecules, atoms in molecules. Then angular momentum equations, because electrons moving around nuclei and in diatomic molecules, they rotate around each other. So if you have this document output, there are recordings from one of the previous years. So if you do not see any benefit from seeing each other in a certain kind of watch it, or even pre-watch it, and then give tricky questions to the instructor, or just look good in front of. The labs are also recorded, but I never watched them myself. I think it is quite boring to see people trying to do the same thing over and over again. But just in case you, so that you do not feel left alone, even if something happens to me, you have the material. I have intentions to come in person, deliver, because I find it beneficial from judging amount of a lot of enthusiasm and feedback. But the materials are there. So the level of complication will ramp up from simple to complicated, and the beginning should start from the discussion of the wavy nature of electrons, just discussing, looking from different angles, maybe watching some simple animations, and then coming up to equations that represent this wavy nature. So maybe it's concept number 4 for today. The math is language of chemistry and physics. So in order, when we go away from very simple things that one can count on figures, one needs to be quantitative. And if you go to such things as like molecules and their properties, one needs to go to advanced level of math, like calculus and above, differential equations, and stuff like that. And in order to practice these things, we need to discuss background and then just try to repeat the path the developers of this areas of science did before. So we will go slowly but surely to get this basic cornerstone, how to convert intuitive expectations into math concepts, and then how to translate it back from solutions of equations into interpretation. And at the beginning, like first half of the class, this translation from concepts to math, from math to concepts, will be more educational rather than practical, because we will focus on quite abstract things in order to pump our mathematical muscles. Because if we start from complicated things, we can break the teeth. We need to practice on simple things. But the translation from ideas to math, from math to back to ideas, is the standard approach in material science, in natural science. So just do not want you to be surprised at the end. I believe all of you are STM, science and technology majors, like chemistry or coding and polymers or physics or engineering. There are no language, history, or philosophy majors. Okay, then the concept number 4 should be quite natural for you. Okay. Just checking that I do not overuse your. So let's discuss what is a wave. Please write down if your definition of a wave, and do not hesitate. Do not hesitate to do something that may sound challenged. Just what do you think when you hear the word wave? Okay. What do you have?
I just said the oscillation of a particle or material.
Okay. Let's listen to everyone.
I said like oscillating energy or light.
Okay.
I just said repeating motions that typically goes up and down.
Uh-huh.
Oscillating function.
Okay.
I wrote it's like a diagram of how electrons move.
Okay. No one is wrong. Everyone is correct. And wave is more general. It's not one-way electrons. It's like surface of a lake, acoustic waves, electromagnetic waves, right? And when we hear the word wave, the first thing that we start imagining is maybe waves on the water after you throw a stone, like oscillations. Everyone told oscillations, periodic. But the wave is more general. When you throw a stone and look only on the line from the center of the stone to infinity, the perturbation appears, moves away, and then comes back to calm at the original place, right? So in addition to this oscillatory wave, there could be traveling wave that not necessarily has this sinusoidal oscillatory form, right? So one of the more general way to think about it is that it's something that repeats, right? Because if you throw a stone and look, there is a like hump on the surface of water and it moves. It changes shape, but very slowly. Mostly, if you look on a short time scale and short range of space, it repeats the same shape in different space and in different time. So it translates the shape. So it's something you've told the function, the word function, right? So if we define wave of what, like electromagnetic wave, wave of probability to find electron, or wave this compression of air in acoustic wave, you can put it as a function or as observable depending on position and time. And it will be a wave in nature if yes. So if the function will be the same in functional form, it will be the same function upon we shift the origin by a certain value, right? And this amount of shift will be time dependent. So it will be exactly corresponding to traveling hump. So function shifted, or origin is shifted by velocity times time, is the same as it was in the time zero. If you do not agree, if it sounds silly or you have some counter arguments, please do not hesitate. Just raise the hand or just start immediately yelling. Wrong, you're a liar. So if no one is objecting, it means you all vote for this definition. Okay. And I think I can mumble further, but maybe if you have organizational question. Does any of you have class immediately following this one? So you need to be somewhere at 1. Then let's finish for the day. We already started lecture number 2, so we are ahead of time. So have a nice day, and Wednesday and Thursday. I'm looking forward to see you on Friday.
No lab tonight.
No. If you are really dedicated, please look how to install MATLAB on your personal computer. It will make you independent, and it will be much more efficient than using facilities in the lab. Thank you.
Thank you.
Yeah, thanks for coming. I think we are winning over any diseases. We are breaking kind of here.